Hello everyone. Today we are going to talk about in branching and logical operations and relational operations. In programming, branching means we can choose the code blocks to execute under some conditions. In other words, it's some conditioning. In Matlab and in many other programming languages, to implement the branching, we use if statements. In Matlab, I'm gonna use my script file to show the if statements. Okay, and let's start with an example if statement. Let's write an if, and after if, we need to write our condition. Let's say a equal to 0. In here, the equal means just equal. That line says that if a equals to 0, then what will we do? If a equals to 0, then I will increase a by 1. And to finish the if statement, we need to use AND. Okay. Right now, when the script runs, the script will check a is equal to 0 or not. If a is equal to 0, then it will increase the a by 1. Let's check it. Let's write a equals 5. Our command window, as you can see in the workspace, a is 5. And if I run my script, as you can see, nothing changed. A is still 5. But if I write a is 0, and then if I run my script again, as you can see in the workspace, the value of variable a is changed. Let's check in command window too. Right now a is 1. Why? Because a was 0, and if a is equal to 0, then the statement will work. And in here, these commands inside the if conditions will work, and a was increased by 1, and so a becomes 1. If I run my script again, nothing will change, as you can see in here. Why? Because a is not 0 anymore, so it will not increase. It will not be increased. Okay, in here we used a relational operator, which is equal. And what is the relational operators? The relational operators in Matlab: equal, greater, lesser or equal or less, something like that. We will see all of them. In here we have 1, 2, 3, 4, 5, 6 relational operators and 2 functions to measure the relation between two or more variables. The first one is determine the equality. The second one is greater than or equal to. We will use greater than or equal to sign. And if we don't use equal, it will means the first one is greater than the second one. And if we use less than or equal sign, that means the first one is less than or equal the second one. And this is the less than operator, and in here there is a difference. It will determine inequality. This is opposite of equality. This is opposite of equal operator. And this tilde in here means not equal. Tilde means not, equal means equals, and tilde and equal means it's not equal. And before we start the relational operators, let's clear our window. Let's clear our parameters. Okay. Let me increase the command window. Just before we start relational operators and logical operators, we need to know that logical variables. There are some logical variables. Let's define a logical variable here. A equal true. When you write A equal true, as you can see in the workspace, the class of A is logical. That means the variable A is logical and its value right now 1. Why 1? Because it assigned as true. So its value becomes 1. If we write here B equals false, as you can see the value of B becomes 0. Why? Because 0 means false, 1 means true. Okay. In here, in the if statement, we give a relational. We used a relational operator. The relational operator measures the relation between two or more variables. Let's check what happens. If I write here, let's define another variable. Let's say v equals 5. And if I write here a relational expression, v equal to, right now we will measure the relation between v and 2. If v is equal to 2, it will return true. It will return a logical value. Let's check it. Now I write that v equal to 2, but it returned 0. It returned a logical 0. Why? Because this statement is false. So it returned 0. If I write here v equal 5, right now it returned 1. Why? Because v was a 5. And also we can use not equal to 5. Now I have a statement which says v not equal to 5. If I click enter, it will return 0. Why? Because v is equal to 5, and I was saying that v is not equal to 5. So the Matlab returned that it's false. It's 0. And if you remember A was true and B was false. So let's check it. And if I write here tilde and A, it will return 0. Why? Because A was true and I used the not operator in front of A, so not true becomes false and not false becomes true, and the same way not B is become true because B was false. And Let's try the other operators, which is greater than or equal. Okay, we had 5, as you remember, and let's check. V is greater than 3. It will return true. But if I use V greater than 8, it will return 0. But if I write V greater than 5, it will return 0 too. Why? Because V is not greater than 5. V equals to 5. If you write V greater than or equal 5, it will return true. Why? Because V is equal to 5. It's the same way we can use the smaller, lesser. We can say V less than 3. It will return false because V is not less than 3. V less than 5, it will return 0 again because V is not less than 5. V is exactly 5. If we use V less than or equal 5, right now it will return true. Let's check them with arrays. Let's create an array. ARR equals to arrays and matrices, doesn't matter. Okay, 1 2 3 4 5 6. I have an array 1 by 6, and if I write here, if ARR greater than 3, the result will be a 1 by 6, a logical array at the same size, but the array type is right now is logical. Why? Because I use the relational operator which is greater than, and this expression will return a logical parameter, and this was an array, so the result will be an array too. In here we have a logical array. How it's computed? Let's check it. I said array is greater than 3. It will check each element of that array is greater than 3 or not. If not, it will return 0. If it is, it will return 1. Let's check one by one. 1 is greater than 3. No, it will return, it's returned 0. 2 is greater than 3. No. 3 is greater than 3. No. 4 and 5 and 6 are greater than 3. Yes, it returned 1 for each of 4, 5 and 6. What if the matrices? Let's create a matrix. Matrix equals 1 2 and 3 4. Oops, sorry. Matrix is equal to 1 2 3 and 4. Yes, I have a 2 by 2 matrix. If I write matrix is greater or equal than 3, right now it will return to me as the same size matrix, but this time the type of matrix is logical, is not double. As you can see in here, the answer, which is the A and S, is 2 by 2 logical, where the matrix was 2 by 2, but it was double. Okay, let's check what happens if I write these things on chars and strings? If I write here A, as you can see, let's say char C equals to A. And what is A? Let's check it. Integer 8 C. The integer value of C is 65. What was that? It was an ASCII code for a character, upper A. Okay, if I write here C greater than 0, it will return true. If I write here C greater than 100, it will return 0. Why? Matlab will convert C to a number, which is 65, and checks 65 is greater than 100 or not. So in this situation it's not, so it will return 0, which means false. Let's check. A is greater than B. It returned 0. Why? Let's check. The integer of A, the ASCII code of A was 65. And what if for B? The ASCII code of B is 66. So this expression will be false. Why? 65 is not greater than 66. And what if equal? If I write here A equal to B, it will return 0. Why? They are not same thing. If I write same thing in here, it will return true. At the same way, if I write C with A, it will return true. Why? Because C was upper A too. Let's continue here. And if I write a char array in here, hello world, equals to something hello. Right now it will throw an error. Why? Because the size of first array is not same the size of the second array. So let's say C equals hello world. And what if I write here C is greater than 30? It returned everything in this array is greater than 30. And let's say 45. Right now it says all of them is not greater than 450. I was reading 45. If I rewrite 45, only one of them is smaller than 45. Because the C was an character array. If I use a mathematical relational operator, Matlab converts C to number array, to double array, or to integer array. It doesn't matter right now because it always returns decimal. And then it will execute this relational operation and it will return the result. The result's size is same with the size of C. And what about, let's write C is hello and D is equal to Hella. Let's compare them. C is equal to D, and the result is 1 1 1 1 and 0. Why? The first 4 element is same with D, H-E-L-L, but the last one is different. In C it was O, in D it was A, and they are different, and this is why the last one is 0. What about strings? As you remember, there are differences between char array and strings. If I write here hello world is equal to A, and it will return 0. In the char array, if you remember, it threw an error because it was saying that the sizes should be same. But in strings, we don't need to do that. Why? Because in that string, my size is 1 by 1. Why? This is not char. This is a string. This is a 1 by 1 string. And this is a 1 by 1 string too. So I can compare them. Okay. And in here, we have 2 more functions. These is equal and is equal and are not operators, but this one is functions that measure the relation between variables. Let's write here A is 5 and B is 6 is equal A and B will return false. Let's write is equal A and 5, it will return 1. That's good. And let's create an array. A is equal to 1 2 3 and B is equal to 1 2 4. If I write here A equal to B, it will return an array which is 1 1 and 0. It's okay. But what if I write is equal A and B, but this times A and B are vectors and arrays? It returned a 0. And if you notice that it's a single logical variable, it didn't return an array like A equal B. This time is equal returned single variable, which is 0. Why? Is equal function compares the whole array. If the whole array is totally equal to other array, then it will return 1. Let's check it. Let's remember A, and it was 1 2 3, and let's change the B the same way, 1 2 3. And right now if I write is equal to B, this time it will return 1. Why? Because A and B is totally same and totally equal. And let's check is equal for strings and char arrays. Let's write here hello world. If you notice that it's a char array, it's not string. And hello, it will return 0. Why? They're not same. And if you notice that is equal doesn't throw an error because of its sizes. It handles it. And as you can see, it will return 0. If I write here hello world, which is total same with the first one, and it will return 1. And if you use in strings, let's use strings hello and no, it will return 0. And if I write the same thing here hello, it will return 1. Is equal works in every conditions, in every sizes. If there is something wrong with the sizes, it will return 0. Why? That the difference between sizes, that means the two variable is not same, so it will return 0. And how about structs? Let's create a struct here. Struct 1 dot field 1 is equal to 5, and struct 1 dot field 2 is equal to hello. Right now if I write here struct 1, you will see that two fields. The first one is 5, the second one is hello. Let's create another struct here. Struct 2 dot field 2, let's say equal to hello. And struct 2 field 1 is equal to 5. And struct 2 is field 2 is hello, field 1 is 5. And struct 1 is field 1 is 5 and field 2 is hello. They are similar, like, right? And let's check is equal struct 1 and struct 2. Right now, as you can see, it returned true. Why? They are totally same things. Just the order is different, but the variables are totally same. So is equal returned true. So let's change any field of struct 1. Struct 1 field 1 is equal to 9. Then if I write the is equal to is equal struct 1 and struct 2, it will return 0. Why? Because the fields are not same right now. So you can use is equal in every data structure in the Matlab. Okay, what if I write here is equal char array, which is hello, and a string variable which is hello 2. It will return true because it's comparing the string values of char array and the string, so it will return true. This is the good thing for us. And in here we have one more function, is equal n, and its description says determine array equality but treating non-values as equal. What does it mean? What is non-variable? The non-variable is undefined number. Non-variable the non means not a number. What is it? If you try to divide 0 by 0 in math, the result is undefined, and in Matlab the result is not a number, none. At the same way, if you divide infinity to infinity, the INF means infinite, sorry, not infinite, infinite, so the result will be none too. And you can assign none to a variable with a none keyword with lowercase. So let's try none equal to none. They are same things, but the result is false. If you compare two undefined variables which are two nonce, Matlab will always return 0. Why? Because these undefined and these undefined, we cannot know they are equal or not, so the result will always false. And is equal and prevent this false situation. How? Let's check. A equal 1, 2, none and 4. A is 1 by 4 matrix and its variables are 1, 2, none and 4. Let's create another matrix here. B 1, 2, none and 4. As you can see, B is totally same with A, and if I write is equal A and B, it will return false, but they are same. Why is false? Why it's false? Because the non-variables. If we compare two non-variables, the result will always be false. To prevent this situation, we can use is equal and A and B. Right now we have true. Why? Because is equal and function will handle the comparison of two non-variables by giving a true. And we can also use this is equal and function in structs too. For example, struct 1 dot field 1 is, let's say, none. As you can see, I have field 1 with none, field 2 with hello. And let's remember struct 2, I have field 1 with 5, I have field 2 with hello. Let's change the field 1. Struct 2 field 1 is equal to none. So right now struct 1 and struct 2 seems similar. Is equal struct 1 and struct 2 will return false. Why? Because it compares none to none, then the result will be false. So we need to use is equal and struct 1 and struct 2 to get true. And we can use all that relational operators in any if statement. We can use any relational operator in that conditional structures. Let's check. I will write my code into script. Let's write S is hello. I'll use semicolon at the end of lines to prevent the printing, and A is 0. And in here I can say if S equal to hello, increase A. And let's write, you can click the run button. As you can see, A is 1. If I run again, A is still 1. Why? Because always in each time I assign a 0 to A. So I remove the colon here. If I write here, now if I run here, you will see that the A will be increased. Run, 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 run. As you can see, each time A is increased. If I write in here, not hello, to hella, right now A is not increased. So this is branching. Why? Because the code in the if statement is executed if and only if the statement in here is true. Okay. And what the statement is not true, now it will skip from here to here. It will skip from the 3rd line to the 7th line. And what if we wanted to execute some codes if this statement is false? If this statement is true, it will execute in here. What if I want to use some statement that I want to run some of code if that statement is false, but at the same time, if it's true, it will work here, but if it's false, it will work something else. I can use another if statement here. I can say if S not equal to hello, and this time I can say decrease A. So I can do that. For example, right now S is hella, So I run it. As you can see, A is decreasing. Run, run, run. As you can see, when I run the script, the A is decreased. The reason, this: if S not equal to hello, then A will be decreased. And I can write these statements together. How? With an else keyword. Why? Because I want that if this statement is true, I want to run this code, and if this statement is false, I want to run this code. So I can write here an else keyword. Right now, if this statement is true, this code block will work. Else, so if it's not true, this statement will work. Let's check it. Let's change S to hello and let's run it. A will be increased. As you can see, A is increasing while I'm running it. And if I change hello to hella or something else, as you can see, A is decreasing. Okay, this is the end of this video, and we will see in the next video. Bye.